Alright, in this video we're going to be predicting the products of a reaction. So the first thing we want to identify is what type of reaction is this. So this first one is a synthesis reaction, and the way that we know that is that there are two elements being combined. There's really not much else they can do but combine, so we have synthesis. So the key thing in synthesis is looking at the charges that will form. Na, when it forms a charge, likes to be Na+. And if you're not sure why that is, go back and double check that. I'm not going to get into it. N, when it forms a charge, is N3-. So this N is going to break apart when it forms our compound. So we don't have to worry about the fact that it was N2 before. It's now different. So what is a stable compound that Na+ and N3- will make? It is Na3N. And that is the product that is predicted. It doesn't matter that there weren't 3 NAs here and there are here now, or that there were 2 N's here and only 1 N over here. It's important to make a stable product. And then, which I won't do in this video, we would then balance this equation to make this work. So we would add the appropriate coefficients to make this balanced. So here's another one, aluminum and sulfur. So aluminum likes to be +3, sulfur likes to be -2. So when we put those together, we get Al2S3. That is the product we're going to predict. Again, I would then balance this later, like using my balance equation method. But that's it. Those are the products I'm predicting. This is the reaction that occurs, and then we're going to go in and add the coefficients afterwards. These are decomposition reactions. The reason I know that is I have one substance. It's making something, so all it can really do is break down. So we say, okay, what's it going to break into? It's going to break into its elements. So Rb is a metal, and metals can be just written as metals, Rb, Mg, Al, whatever the case may be. So that's one product. Then oxygen is the other product, but O is one of these diatomic elements. Remember, there are 7 of them on the table. There is H, N, O, F, Cl, Bri. Those will never be totally by themselves. They'll be diatomic. So these are the products, Rb plus O2. And again, after the fact, I would go back and I would add the coefficients necessary to balance it, which I'm not going to do here. GaF3, one product is gallium. It's a metal. I can leave it as is. The other is fluorine, which we know is diatomic, so Ga plus F2. And those are the products I'm going to predict there. So that's decomposition. And the last one I'm going to do in this video is combustion. And combustion is kind of like saying burning. Combustion you can identify by, it's usually a hydrocarbon, like carbon and hydrogen molecule, reacting with oxygen, which is what is needed to burn. When something burns, it requires oxygen. So what does it make? Anytime something burns, we're pretty much going to be making CO2 and water. So when you have a combustion reaction, the products are pretty simple. It's CO2 and water. The tricky part of combustion is then balancing this, but predicting the actual products themselves, pretty much just CO2 and water each time. Now there are combustion reactions that can be slightly different, but your standard typical ones, this is what you're going to predict. And that's it. So that's how you predict 3 types of reactions. In another video I'll do the other 2. Until next time, this is Derek Genova. Have a delightful day.